Uh, yeah. Okay, here we are again. Uh, I had some really hefty connection problems yesterday. So as for Advent of Code 7, this will only be a recall of what I did yesterday. So, let's have a look at what we let's look at the problem first. Day 7. Okay. Um, we have a teleporter hub. You're in a room. There is a teleporter. Unfortunately, it seems to be leaking. Leaking magic smoke happens all the time. I've heard. Um, we have a diagnostic. We have some diagnostic tool, and it displays an error code OH-NO, which means that we have arrow down here. We have a diagram of the Tachyon manifold, which is our puzzle input. A Tachyon beam enters here and then wanders down. Whenever it encounters this sign here, this character, it splits into two that continue to the right and to the left, but downwards, like this. And this repeats. So, what it looks like in the end is this. Coming down here, splitting here into a right and a left part, and so on, whenever it encounters this character. So, how did I do that? How did I do that? Let's go to the code of 701. Okay, I read the file. Not need not line number. Then I split the lines. I split the lines into an array. So now I have a data array. And then for the second line of this array, which is this one, I set a vertical line at the location of the character S in the very first line. So this is just putting in this vertical line. Then, starting with this, and always taking into account two lines, the function which will alter the second line and give it back. So, also, for the first part, it will count the number of lines. It will count the overall splits. So in the end, it will show me what it's got. So we move down. We have two strings right here. We split the string. We split the strings into an array of characters, and then we step through each character in line 1. If it is a vertical string, and if A2 at the same index is a this character here, a caret, then we indicate the vertical string split right here. This is, if this is a vertical string, this is a caret, then put one vertical string to the left and one to the right. If there is a vertical string, but no caret below it, which is like this here, then just repeat the vertical string in the second line. So that's about it for the first day. If you run it on the real data, it looks like this. And we get our result here. Which we also see reproduced. Okay. With the second part, I have to say I struggled. Because I didn't want to do a recursive solution, which would have been the logical thing. I don't know. I just didn't like it. I thought there must be something that's easier. And indeed, there is something that's easier than that, which only requires stepping through the lines vertically. And the solution is surprisingly simple. Solution is surprisingly simple. Okay, what was the problem? I just make it short. They suggested that you have to calculate each kind of way. You have to look at it like a binary, not a binary tree. Oh yes, a binary tree, and go through each of the 2 dimensions, the left and the right link, from each caret. So this would require recursive processing, but it's easier. The easiest solution is yeah. I'll explain it with sample data. Okay, this is the complete number of lines. Right here, we have 1 coming from above. Right here, we have 2. The one that we have from above split into a 1 here and a 1 here. So these add up to 2. This is still 2. This is just the line in between. And now, whenever we appear at something like this, logically, we add the number that's coming in on top to the left part and to the right part, and we make the center part where the caret is 0. So what we have to do then is we have to we have to generate a sums array. We proceed the same way that we did before, and we initialize the sums array at the part where the first at the index where the first s appeared with the value of 1. And then we do the same stuff. We go down the strings, and then we can and then we add them up. That's what I did right here. I said it's the part where the sums are added. The one to the index to the left and the right. When we hit a caret, will be added with the value of what it actually is at the caret, and then the index at the caret is 0. And quite magically, if I console log this, you will reach this. I can elaborate further and show you in an example. Okay, here you see all parts of the sums array that are not 0, like here. So we have a 1 here, and we have a 1 here. 1, 1, that's 2. Here they split again. We add this value to this value and this value. Also, we add this value to this value and this value. So from here to the right, we have 1, and from here to the left, we have. That is, this here, the first one, the first vertical line has a value of 1. The second has a value of 2. Third has a value of 1 again. And this is how it continues. And quite magically, you will see that the last value is 40, which quite magically aligns with what they say the max is. Okay, now let's do that for the real data. Keep it readable. I'll do it this way with a little less console logging. And you see we arrive at a real big value like this. Magically, it's correct. I thought about it a little, I have to say. So, in all, this solution took longer than the last ones, the last days. I cannot tell you how much longer. I figure it may have been around 3 hours overall for both of the parts. Yeah, I'm quite satisfied with it, especially since I think this is a solution that is much more elegant than doing it recursively. And also, this is very memory efficient. A recursive solution would have required much more space, either on the stack or in the heap if you do copies of the original string array. So this is quite elegant, I guess. I guess. You can correct me if you disagree. So anyway, um, now I think I will stop uh, the day 7 stream and restart it because I want to have separate streams for each day. So this is a very short one, and I'll be back in a minute or two. Okay, see you in a minute.